So this is what March 21, paper 22. So starting with the first question, which is about Boltzmann distribution. Not sure what happened here. So that's about Boltzmann distribution. It's a distribution of molecular energies that you have in a particular solution or in a particular gas. So draw a curve on the axis to show the Boltzmann distribution of energy of particles in a sample of gaseous. It's a sample of gaseous Krypton atoms at a given temperature. And so this axis over here is your energy axis. The other side is the number of particles. So the curve is always kind of skewed to the right. This is how the curve looks like. What that basically shows is that most particles, the height of the curve is the number of particles. So what it shows is that at average energies, let's say this is your average energy, like if your room temperature is 25 degrees centigrade, temperature is basically proportional to the kinetic energy of the particle. So let's assume this is 25 degrees centigrade. So most particles would have energy. So the number of particles would be highest at 25. At very high energy, this end is your high energy end. So at very high energy, the number of particles would be very less. And at very low energy as well, the number of particles would be very less. So most particles in your room would be around room temperature. Fewer particles, the height decreases. That's the number of particles. So the height decreases, it becomes lesser. So it would be very rare. The particles are bumping around. If you look at the gas particles in your room, they're all randomly bumping into each other. So when they do that, some would lose energy, some would gain energy. So they're not all at the same temperature, but most of them are close to the average energy. Most of them would be around 25. Some would be at 28 degrees centigrade. Some would be corresponding to kinetic energies that would be close to 20 degrees centigrade. But most of the particles would be around this particular energy. There would hardly be any particle at, let's say, 1000 degrees centigrade. So the number of particles at higher energies, they would decrease, and the number of particles at lower energies would also decrease. So on the diagram, draw a second curve to show the distribution of energies of kryptons at a higher temperature. So what happens at much higher temperatures? At higher temperatures, the number of particles having higher energy is larger, and the number of particles having lower energy, that is actually lesser. So at higher temperature, you have to show the distribution of energies at higher temperatures. So just remember, the number of particles at higher energies would be greater, and the number of particles at lower energies would be lesser. So the curve gets skewed to the right, and it becomes flatter. The peak of the curve, which represents average energies, that also shifts towards the higher energy end, because now the average energy is also. So most particles would now have energies that would be much higher. So the curve moves to the right, and it becomes flatter. The particles are more distributed. So this curve is T2, and the previous one was T1. T2 is at higher energy, and T1 is the one that's at the lower energy. It's a lower energy curve, or the gas is at a lower temperature. So is that clear? This is Boltzmann distribution. Is this part clear? Tanya, is this clear? Osva?
Yes, sir.
And then you have the Boltzmann distribution assumes that the particles behave as an ideal gas. State two assumptions of what an ideal gas is. So ideal gas behavior was, it's a model of a gas. When you look at a gas, what do you see? You see two things. You see particles that are far apart, and these particles are haphazardly, randomly moving around. So that's what your O-level model for a gas is, that the particles are really far apart. They're moving randomly and freely in all directions. They don't have a lot of intermolecular forces. Now, the two main assumptions of an ideal gas. An ideal gas is simply a model of a gas. Like, how do you think of a gas? What is a gas? So the first thing is that they have negligible intermolecular forces. That's the main assumption, that they have negligible intermolecular forces, which is why they're freely moving around. No one is stopping them. They're all freely, randomly moving around. If they had strong intermolecular forces, then they would either be in solid state or they would be in liquid state. They would not be in gaseous state. The other one is, the other assumption is that that most of the gas that you see, that's just empty spaces because the particles are really far apart. So that assumption is that the volume occupied by the gas is volume of the particles of gas particles is negligible. So that is negligible compared to the total volume occupied by the gas. Compared to the total volume that the gas occupied by the gas. So what does this statement mean? It means that if I have a container and these gas particles are moving in that particular container, then the particles are occupying the entire volume, this big volume. But the volume of the particles themselves is negligible. Like if I pick these four particles and I put them together, they would be negligible. So most of the container is just empty spaces. So when you look at a gas, what you see is just empty spaces. So the volume of a gas is basically equal to, I mean, it's the volume of the empty spaces. So it's the empty space plus the particle volume. And the particle volume is kind of negligible, which basically means that if you see gas around, it's just basically empty spaces. There's hardly any particles in it because they're so far apart. So is that point also clear that whenever you see a gas, it's just empty spaces, which is why it is compressible, because you can bring the particles closer to each other and you can bring the particles further apart from each other. Solids and liquids are not compressible because they would be tightly packed. So is that clear? The second assumption.
Yes, sir.
So then the next one is, so remember these two are the main assumptions these two are the main assumptions for ideal gases. Negligible intermolecular forces, freely moving around, which is why, because they're freely moving around, and this means that it's mostly empty spaces, that the particles are themselves not occupying that much space. It's a very tiny particle. It's most of it is just empty space. Now the next one is you've got show your working. Basically, if he's talking about ideal gas, it's probably going to be a question about PV is equal to nRT. So sign calculator nikalo, you solve for. You've got 2 grams of krypton gas. So if you've got 2 grams of krypton gas, you can find the moles. So krypton, what's the AR of krypton? Doesn't even know what's the AR of krypton. Something around 80, I think, because it's right after bromine. Just a second. Krypton mass number. Just a second. 83 point. Let's call it 83.8. So krypton, you can find the moles of krypton, mass divided by 2 grams divided by the, what was it? 83.8. R is 8.31 for an ideal gas. No, Tanya, we haven't done. I mean, we'll do inorganic again as well. And I will share the notes with you as well.
All right, thanks, sir.
Make sure you remind me again. It's inorganic is simple. It's just mostly memorization of facts. But we'll do that again. Now this one, 8.31, the temperature is 120 degrees centigrade. The temperature has to be in kelvins. You have to be careful about the units. It's going to be 120. It's 120 plus 273 in kelvins. So that's moles. R is the gas constant. T, the container volume is 5 dm cube, but it should be in meter cube. So if you want to convert dm cube into meter cube, it's going to be divided by 1000. So it's got to be meter cube, and then you'll be able to figure out the pressure. So he is asking you to calculate pressure. So remember the units. Volume should be in meter cube. Make sure if it's cm cube, you divide by million, 10 power 6, 10 power minus, or multiply by 10 power minus 6. I mean, I'll write that down as well. Like if it's given in cm cube, you multiply it by 10 power minus 6. If it's given in dm cube, you multiply it by 10 raised to power minus 3. So that's how you'll get the volume in meter cube. Pressure should be in pascals, and temperature should be in kelvins. So how do you convert that? It's degrees centigrade plus 273, and you'll get the temperature in kelvins. And R remains. So is anyone calculating this?
Yes, sir. 15,588.
So 15,588 pascals. Okay. Okay, let's open a marking scheme as well. Just 1 second, so we can double check. Remember, you be careful with your calculators. You can make a lot of silly mistakes. Even this calculation, you can end up making a lot of. Be careful with calculators. So just a second, let me have the. Yeah, that's the number one source of error, that people make mistakes while using the calculator. They don't make mistakes while doing this. I mean, they'll do this very well, but when they shift this on the calculator, they make a lot of mistakes. So this one hopefully is right. That this one is 15,600 pascals, which is kind of the same thing. Now, there's a question over here. Why did he write 15,600 and why not? So now this is an important question because they might cut marks for that as well. So the question is, why did he give this as 15,600? And while 1588 is basically a better version, a correct version of that. The reason is significant figures. Like if you look at the significant figures, make sure this is 3 significant figures.
सर
हाँ जी,
सर आज आपने कहाँ से स्टार्ट किए?
ये हम पेपर कर रहे हैं ऐसे हम पेपर कर रहे हैं, ये वाला, ये बॉटम पे लिखा हुआ है मार्च 21 फर्स्ट क्वेश्चन है, ठीक है मार्च
सर
हाँ
सर वो जो मंडे और ट्यूसडे का आपने क्लासेस ली थी, क्या आप वो अपलोड कर सकते हैं?
वो मैं उधर ही फंसा हूँ अभी, एक सेकेंड, वो मैं एंड में करता हूँ, ठीक है, वो मैं उधर ही स्टक हूँ। बल्कि इसको भी ना एक और काम मैं कर सकता, आई कैन गो लाइव ऑन यूट्यूब, फिर वो सेव हो जाएगी। बल्कि I'll figure this out कि why the videos are not getting converted, ठीक है। तो ये क्लास के एंड में करते हैं, फिर इसके बारे में सोचते हैं, ठीक है। तो वो बैठे रहना, देखते हैं वो शायद हो जाए। अच्छा, दिस वन, कमिंग बैक टू दिस, कहाँ पे थे अभी? हाँ, वी वर स्टक एट दिस. I was asking you, why did he use 15,600 in the answer and why not this thing? Make sure this is, make sure don't do this. I mean, this is the correct answer. This one technically is not the correct answer, even though this is the one that you're getting on your calculator. And the reason is accuracy. What 2.00 means that he doesn't know what comes after this second decimal place. So that represents accuracy. And 5.00 means, so that means if the original values are accurate up till 3 significant figures, your answer cannot exceed that accuracy. But if your measurements are accurate up till the third number, how can your answer be more accurate than the original values? So this one cannot be more accurate than 3 significant figures. So you would have to round it off on the third one. It's going to be 15,600 and not 15,588, because your answers cannot exceed the accuracy of the numbers that you're using. Is that clear? Time clear?
Yes, sir.
So make sure everyone, okay, your answers, they should not exceed the original accuracy. As anyway, State explained the conditions at which Krypton behaves most like an ideal gas. So two things. When would a gas behave as an ideal gas? When the intermolecular forces are negligible. When are the intermolecular forces negligible? At higher temperatures. At higher temperatures, anything would behave as a gas because the particles would be so energetic that they would easily overcome the intermolecular forces. That's what a gas is. And when will the particle volume be negligible? At lower pressures. At lower pressures, so at lower pressures, gas particles would be really far away from each other. If you compress it, the problem would be that if I take a gas and if I start compressing it at higher pressure, so what will happen is if I start moving the piston downwards, the particles would all become like really close to each other. And if they become really close to each other, they would liquefy. They would stop being a gas because if the particles are really close to each other, they would start attracting each other. Remember, forces are inversely proportional to distance. Like any force, like gravitational force, if two bodies are really far apart, the gravitational force would be very weak. If two charges are really far away, the attractive force, electrostatic force would be very weak. What's the third force? If two magnets are really far away, then the attractive force between them would be very weak. So if you bring them together, any particles if you're talking about any type of force that exists between particles, whether it's intermolecular forces or a bond or whatever. So what happens is that higher pressures, particles, they stop behaving as a gas. Why? Because if you bring the particles close together, they would liquefy, they would start attracting each other. If the particles are really far apart, they would behave as a gas. They would be really far apart if they're at a lower pressure. If you decompress it, if you take it to a lower pressure. So are the two things clear? Is this clear? Yes or no?
Yes,
Is this
sir.
Okay, so just remember, higher temperatures, they're easily able to break the intermolecular forces. They would start behaving as a gas. Lower pressures, the particles would be really far away. If you compress it, take it to a higher pressure, they would liquefy and they would stop behaving as a gas. So the answer to this is under what conditions would it behave as an ideal gas? The answer would be lower pressure and higher temperature. I don't know if they're asking or looking for the explanation for this, but you can write the explanation and we can. So that's the assumption. Which one? Look, it's so Mark 1 is for low pressure and high temperatures. That's Mark 1, and the other one is for the explanation. That so you have to give the explanation. So it's either one. I mean, explain either one of them. So the forces, intermolecular forces, would be insignificant due to higher kinetic energy, and if the particles are at a lower pressure, the particle volume would become negligible compared to the volume of the container or the total volume of the gas. So you have to give the explanation as well. Okay, Tanya, is this clear? The previous one.
Yes, sir.
Now the next one is Krypton reacts with fluorine in the presence of ultraviolet light. There's a reaction given. The activation energy is given, and the enthalpy change is given. So this one looks like an endothermic reaction. I mean, it is an endothermic reaction. Doesn't look like it's got a plus written over here. So it's an endothermic reaction. So if I draw or sketch the energy profile diagram, would the products be higher or would they be lower for an endothermic reaction? Where would the products end up? Higher or lower? It is one sign.
Products will end up higher.
Because the products would end up, yeah, it's an endothermic reaction. So the products would end up higher because they're gaining energy overall. So the products, so enthalpy change would be this one, that they gain this much energy. Delta H is the overall energy change, and that's plus 60. This is delta HF. I mean, they wrote this delta HF. And this one is what is Haji?
सर अगर वो प्रोडक्ट नीचे होता तो फिर वो एक्सोथर्मिक होता.
हाँ एक्सोथर्मिक होता है. एनर्जी प्रोफाइल ये O levels का ये क्वेश्चन. In O levels you made these graphs. So enthalpy change is the net difference, and activation energy is the energy that is initially needed from the reactants. I mean, this is from the reactants. And that is your EA. That is plus 385. So it's the activation energy for the reaction. So that's the initial energy that is needed to climb. Why do you need energy? Because you need to break bonds first. And then bonds would be formed. And the reaction would release energy. Is that clear? So I think you just have to label all of this. That's just 2 marks. Now explain in terms of, so is this clear?
Yes, sir.
Now next one, explain in terms of activation energy and the collision of the particles, how an increase in temperature affects the rate of a chemical reaction. So that's a simple question. Higher temperature, what happens? More kinetic energy. So what happens? 2 things happen. You see these particles, right? If they're at a higher temperature, they're traveling faster. If they're traveling faster, the 2 collisions would always be described in 2 ways. One is the frequency of collisions. Like how many times do they collide? So it's the collision frequency. And the other description is how violently they collide or how effective is the collision. Like if they bump into each other slowly, probably the reaction will not happen. You need to break the old bonds. So they need to bump into each other with a lot of force. The collision has to be very, very strong or effective. So it's got its effectiveness or the successfulness of the collision. So collisions are always described in 2 ways. Now, when you have a higher temperature, both increase. I mean, this is what you're going to do because the particles are traveling faster, so they bump into each other a lot more. Plus, they're traveling faster, so they bump into each other with a lot more force, which is why it's a more vigorous reaction. Is that clear?
Yes, sir.
Now, next one is now this is about inorganic chemistry. So the first thing is let's open inorganic chemistry just a second.
सर वो क्लोरीन तो बैक्टीरिया को मार देता है ना इसलिए.
हाँ. So पहले तो he was saying that chlorine is like where's group 17? Just a second. So group 17. So chlorine, remember the color? It's greenish yellow. Actually, a much better. I mean, not this board. Just a second. So let's use this. So chlorine is greenish yellow, and he was using the word oxidizing agent. So this is the oxidizing ability. Like all these halogens, they really like to gain electrons, especially the top ones. They're very electronegative. Fluorine is a small atom. It really likes to gain electrons. So anything that wants to get reduced, that's a good oxidizing agent. So oxidizing ability, it decreases down the group. Iodine is a big atom. It doesn't like to gain electrons because it already has 53 electrons. So its nucleus is already covered with electrons and it's very well shielded. So it's very hard for iodine to actually gain even more electrons. So iodine is a pretty bad oxidizing agent and fluorine is a very good oxidizing agent. So oxidizing ability decreases down the group for the halogen. But anyways, he was asking about it killing bacteria. So this is these are uses of halogens. Cl2 kills bacteria. Why? Because if it reacts with water, it forms HCl and HClO. It's HClO that's actually the one that kills bacteria. So coming back to the paper, and let's even check the previous answers.
Sir? सर वो Cl का आपने बताया था ये disproportionate reaction होता है ना?
Yeah, this is disproportionation. So how is it used? I mean, what you can write over here is that Cl2 first thing reacts with water and forms HCl and HClO. It's a 1-mark question, so they're probably not looking for an equation. It's a disinfectant and it kills bacteria. That's probably the line that they are looking for. So just for 1 mark, let's just check what that 1 mark for. Just killing bacteria, that's it. Nothing else. And then they're saying that chlorine has the highest, this is an ionization energy question, consider an equation for the first ionization energy. So you have a gaseous atom and you remove one electron from it. So it becomes +1 ion and 1 mole of electrons are lost. So why do ionization energies increase across the period? What happens when you move across the period? Why do they increase?
Atomic radii कम बढ़ता जाए.
I mean, the three factors that you're going to comment on, although it's just 2 marks, but CL over here is 17, right? So first thing is, why are electrons more difficult to remove when you move across the period? Because you have more protons on the right, more nuclear charge, right? So the first factor is you've got more protons or nuclear charge. And you have the same number of shells. This is 281, this is 3 shells, 287. So you've got the same number of shells, but what happens is that these shells over here, the atom size decreases, atomic radius gradually decreases. Why? Because if you have more protons, the shells are attracted more strongly. So the distance of the outer electron and the nucleus decreases. And the shielding remains constant. So you can mention that as well. So remember, across the period, atomic radius decreases. I mean, I can show you it just gradually decreases. So it's not a very massive decrease, it's just a gradual decrease. I mean, this kind of gives you a good idea. So they have the same number of shells, but look at the nucleus. You've got more and more protons, 17 protons. So they have a much stronger attraction for the electrons. So the electrons, so the atom is kind of shrinking slightly. Is that clear?
Yes, sir.
So where's the question? So three factors.
Sir, वो size इसलिए decrease होता है क्योंकि ज़्यादा protons होते हैं.
हाँ, क्योंकि the shells are the same, right? You have this 3 shells, this is 3 shells. So they have the same number of shells. But the first one has few protons, so it's not attracting its electrons very strongly. Clear?
Yes, sir.
So you're going to make sure you write one statement at the end whenever you're describing. Therefore, because of the above, the attraction of electrons to the nucleus increases, or attraction of valence electrons to the nucleus it increases. Make sure you add that, and we'll just it's just a 2-mark question, but we'll just so he didn't give marks for distance, but so remember this one. Always make sure when you're writing, and this is something that they've started doing now. They always give 1 mark for this statement at the end. That because of the above factor, although it's a very obvious statement, but because of the above factor, there's greater attraction of nucleus for valence electrons. Is that clear? Although the distance part was also correct, but that no marks were given for that. Okay, so make sure this statement, especially for not just list the factors or the reasons. Make sure you add this statement at the end always. Is this clear? The last question.
Yes, sir.
हाँ जी.
Sir, लेकिन वो जो question के requirement वो तो complete कर देते हैं ना?
कौन सी? नहीं, क्या क्वेश्चन था?
नहीं सर, मेरा क्वेश्चन था कि वो जब आपसे लाइक पूछ रहा हो कि क्या फैक्टर्स हैं, तो हम लोग क्या फैक्टर्स बता दे तो ये ना लिखे तो फिर मार्क्स तो नहीं कटेंगे, क्योंकि हमने
नहीं,
तो
मैं वही कह रहा हूँ
requirement पूरी
कि
करी question.
अब से व्हाट्स हैपनिंग इज Okay, in the marking scheme, they're giving a mark for this. I mean, this is the latest paper. So previously, I mean, you just had to explain the factors, right? Why there's a general increase. So you had to explain the factors, right? The shielding is constant, you've got more protons, and the atomic radius is also gradually decreasing. But they always have now started giving marks for this one statement at the end. So make sure you write this statement that because of the above factors, although this is not required, I know that this doesn't make sense. Why are you writing this? But make sure you start writing it because they've started giving this one extra mark for this thing. That the nucleus is now attracting the valence electrons more strongly. Clear? Mark number 2 is for that. Is that clear?
Okay, sir.
So in all ionization energy questions, make sure, even if it's not required, make sure whether it's decreasing or whether it's increasing, you explain the factors and then you write this statement. That because of the above factors, either the attraction is decreasing or it's increasing between the nucleus and the valence electrons. So what's the next one? Thermal stabilities of the hydrogen halides. So this is about so he's talking about HCl, HBr. This is about inorganic and chemical bonding. So which bond do you think is the strongest and why is it the strongest? Do smaller atoms make stronger bonds or do bigger atoms make stronger bonds?
Sir, HI होगा.
Weakest or strongest?
Sir, strongest, I guess.
Nee, this is going to be the weakest. Remember this applies across the period to all bonds. Bigger atoms, they always form weak bonds.
Sir?
Oh.
लेकिन हम लोग ये थर्मल स्टेबिलिटी क्या उसके लिए नहीं पढ़ते थे मैग्नीशियम के लिए कैल्शियम स्ट्रॉन्शियम इनके लिए
नहीं इसमें if you look at the notes, where are the notes? वो तो carbonates की थी ना, that's group 2. If you go over here, thermal stability, it's this one. I mean this part. Achha, this part over here. The thermal stability decreases to HI. Because bigger atoms, their bond becomes really weak. Why does it become weak? Because Because if you have a big atom like hydrogen bonded to iodine, right? So there are 2 electrons. The iodine nucleus over here, let's say this is iodine, it's got 53 electrons, it's got lots of shells. So why would the nucleus attract hydrogen electrons in the first place? So what will happen is that these electrons over here would be very weakly attracted to the iodine nucleus because the iodine nucleus is very it's shielded and the nucleus is very far away from the shared electrons. Is that clear?
तो सर इसकी फिर इसका मतलब है इसकी चार्ज डेंसिटी कम पड़ जाएगी.
हाँ मतलब इस पे there are a couple of things that you write. When you have a bigger atom, right? Like smaller atoms, they tend to be they tend to make stronger bonds. I mean, let's say I have a fluorine molecule, okay? Okay, let's see if I can just find this on Google. Just one second. Fluorine molecule, and I've got an iodine molecule. Okay, dot and cross. So maybe let's go with this. And they're just drawing the outer shell. I wanted to show the whole cross with all shells. No, they're mostly outer shells. So the thing is, this is how you're going to describe this. And if they ask for the reason, they're not asking for the reason. Smaller atoms, they always make stronger bonds. If they ask you for the reasoning, there are a couple of factors. First thing, shared electrons are really close to the nucleus if it's a small atom. close to nuclei of both atoms. That's factor number one. Shared electrons are going to be really close to the nuclei of both atoms. So if I have this and I've got another one, so I've got another one and they're two small atoms, right? And if they start sharing electrons, the shared electrons would be very close to both nuclei. So there's going to be strong attraction. This is known as bond length. So they have a shorter bond length. Like if they form a sigma bond, it's going to be a really short bond. So shorter bond length would always be stronger. And since they are close together, they're attracting each other's electrons very, very strongly, which is why there's going to be greater orbital overlap. These are the words that you're going to use to describe why smaller atoms make stronger bonds. Is that clear? I guess it's clear that they have a shorter bond length and there's greater orbital overlap.
Okay, sir.
Yes, sir.
So HI is the weakest. It's a bigger atom. So the word that you're going to use is, because you have to explain this as well. So state this. We've stated this. This one is the weakest. This one is the strongest. Now you've got to explain this. So weakest because bigger atoms. What you're going to do is they have a longer bond length or larger bond length. And what's the other factor? That so there's going to be less orbital overlap. They won't be attracting each other's electrons that much. Anyway, so main sulfur oxidation number of sulfur over here. So what's the oxidation number of sulfur over here? HSO4 minus 1. We can do the working. So if I've got HSO4 minus 1, the first one is plus 1, sulfur is X. Oxygen is minus 2, and that's 4 of them. And the total charge on this entire thing is minus 1. So if I solve for X, what do I get? I'm going to get plus 6. So I'm going to get plus 6. Add up the charges of all the individual atoms. Sulfur is unknown, that's X, and it's going to come out to be minus 1 because the overall charge is minus 1. What do you think is SO2? What's the oxidation state of sulfur over here?
+4.
Yeah, that's plus 4. What about the next one? And the reason it's plus 4 is oxygen is minus 2. And the overall molecule is neutral, so it's going to come out to be plus 4. What's H2S? Sulfur is
-2.
So that one is minus 2. Because H is plus 1, there are 2 of them. And sulfur is X. And it's equal to 0. It's a neutral molecule. So complete the table to show the oxidation numbers. We did that. Explain why different sulfur-containing products are produced when each of these halide ions react with concentrated sulfuric acid. Now, this is about inorganic as well. So he's saying that these things are reacting, and they're not reacting. What he's saying is, what he stated is that these ions are reacting with H2SO4. I minus 1 as well. And when they react, the main sulfur containing product that is formed is over here is HSO4 minus 1 ion. Over here, you got SO2. Over there, you got H2S. So what is happening? Sulfur is getting reduced. I minus 1 is a good, you can read the table by just looking at it. You'll notice that the oxidation state of sulfur is going down. So when the reaction happens with I minus 1, that means it got reduced by a big margin. So I minus 1 is a stronger reducing agent compared to Br minus 1. And Cl minus 1 happens to be the weakest reducing agent. So I minus 1 is a pretty strong reducing agent, because even if you don't know this, you can just read the table. This is what's happening. The sulfur containing product that is getting formed is getting reduced. I minus 1 reduces it to the lowest number. So that means I minus 1 is one of the most powerful reducing agents. Is that clear? Haji.
सर जो ऑक्सीडेशन की लाइक लेवल पर अगर देखें तो वही रिड्यूसिंग एजेंट होता है ना, जो ऑक्सीडाइज कर रहा था रिड्यूसिंग एजेंट होता है, तो जो सबसे ज्यादा स्ट्रॉन्गेस्ट ऑक्सीडाइजिंग होगा उसका सबसे स्ट्रॉन्गेस्ट रिड्यूसिंग एजेंट नहीं होगा फिर?
नहीं, वो तुम दो चीजों को कंफ्यूज कर रहे हो, ठीक है? लेट्स गो बैक टू दिस, ठीक है? So remember, this is something that is confusing. When you talk about halogens, the top one, the element is the one that wants to gain electrons. So it acts as an oxidizing agent. Okay, so fluorine is one of the most powerful oxidizing agents. It's one of the most powerful oxidizing agents in the probably in the whole periodic table because it's one of the most electronegative elements. It's the one that likes to gain electrons, and it really likes to gain electrons very, very strongly. So it's a very good idea is a bigger atom, so the oxidizing ability decreases. It doesn't like to gain electrons. Over here, we're talking about the reverse. We're talking about the negative ions. When you talk about negative ions, so we're not talking about the element. Is one clear? Okay, we're not talking about the element. In this question, we're talking about the negative ions. The negative ions, they're not going to gain electrons. Instead, they're going to lose electrons. So I minus 1 would lose electrons. F minus 1 can also lose electrons. So a bigger ion would lose electrons more easily because electrons would be very far away. So that will get oxidized very easily, and that is the one that's going to be a good reducing agent. Clear?
Yes, sir.
So I minus 1 is one of the most powerful reducing agents, followed by Br minus 1 and Cl minus 1. It doesn't like to lose electrons. Like if you look at your table salt, that's NaCl. It remains NaCl. It remains Cl minus 1. It doesn't want to lose electrons. It doesn't want to turn Cl2. You've never seen in a table salt box NaCl that contains NaCl all of a sudden turning into a greenish yellow gas. It never happens. So it doesn't like to lose electrons, but I minus 1 really likes to. Like if you had a salt of NaI and you put it in a box, maybe after some time the I minus 1 would lose electrons to form I2. Anyways, this is something that's very important in group 17 that you have to learn this, that the negative ions, especially the reactions with sulfuric acid. Now, NaCl with sulfuric acid would not be a redox reaction. It would only be a displacement reaction. What would happen is that the Cl ions would combine with the hydrogen ions in the acid, and they would turn into HCl gas, and they would leave. A misty white fume would be formed. What would be left in the solution would be sodium ions and sulfate ions, and they would form sodium sulfate, or if it's concentrated, there would be hydrogen ions as well. But when you move down the group, Br minus 1 and I minus 1, they become really good reducing agents. They like to lose electrons. So what happens is that instead of a displacement reaction, you start getting an oxidation or redox reaction. Br minus 1 starts to lose electrons to form bromine. I minus 1 does exactly the same, which is why sulfur ends up gaining electrons. It ends up getting reduced. So although this question is based on the same thing, but in this question, you could have just figured this out by just, it's just a 1 mark question. You could have figured this out by just looking at the products that are getting formed. Is that clear?
Yes, sir.
Yes, sir.
Next one is Cl2 reacts with, this one is also inorganic. So Cl2 reacts with NaOH. This one is over here, this proportionation. Cl2 reacts with cold NaOH, it forms NaCl, NaClO, and H2O. Cl2 also reacts with hot NaOH, and it produces NaCl, NaClO3, and water. What is disproportionation? That means Cl is getting oxidized and reduced. So Cl is 0, over here it's minus 1, over here it's plus 1. Cl is 0, over here it's minus 1, over here it's plus 5. So it's getting reduced and oxidized. So you got to remember both of these reactions. That what happens when chlorine is added to cold NaOH, what happens when chlorine is added to hot NaOH. And this is a very popular question. So state what is meant by disproportionation when the same, I'll just write, when the same element gets oxidized and reduced. So he's asking about cold NaOH. So you just have to copy the.
सर उसकी disproportionate क्या आप exact wording बता सकते हैं?
When the same element gets oxidized and reduced in a redox reaction. So when the same element gets oxidized and reduced in in a redox reaction. And he's asking us to copy the same equation. With cold NaOH, it's going to be NaCl plus NaClO plus water. And you can balance this. This is going to be 2 NaOH. That's it. So make sure you remember this. This one is about dative bonding. He's asking draw a diagram to clearly show the types of bond present. So you've got an AlCl3 molecule. And all of them are covalent bonds. And you've got another AlCl3 molecule. So this is about dimerization. What happens is aluminium's outer shell is not complete. It needs 2 electrons. And Cl has 6 lone pairs. So what happens is aluminium ends up forming a dative bond with the Cl from the neighboring AlCl3. Aluminium, remember, it's got 3 electrons in its outer shell. It bonds, it makes 3 bonds, so that's 6 electrons. 8 electrons are still not complete, so it still needs 2 electrons. So they end up forming a dative bond. The other Cl does exactly the same. It forms another dative bond because there's another Al, and they would end up forming a dative bond. So these arrows, they represent dative bonds, and you can label them. Like these are your normal covalent bonds. And these ones over here, these are your coordinate or dative bonds. So just a 2-mark question, we can just go and have a look. I mean, that's it. I mean, you don't even have to show the lone pairs, but we did. So that's kind of a better version compared to that. And describe what will happen when aluminum chloride reacts with water. So this again is, you just need to know the reactions of chlorides with water. What happens when aluminum chloride reacts with water? It forms aluminum hydroxide and HCl. That is what happens. So coming back to this, so you're saying describe what you would see when aluminum chloride. So it's not, you don't have to write the reaction. What you're going to see is white fumes. You're going to see an acidic, probably not, you won't be able to see the acidic solution, so that's probably not. We'll check the marking scheme. It's going to be a solid precipitate that's going to be formed. So solid precipitate, what you would see. So remember, the question is about seeing, not about writing what the reaction is. So you wouldn't get marks for writing the equation. So if you look over here.
So साथ में वो नहीं लिख सकते कि misty fumes नजर आते हैं?
वो लिखा हुआ है misty fumes. We wrote that. Actually, मैंने लिखा था, but I didn't write that. Because I told you acidic solution, you wouldn't be able to see that. So misty fumes are seen. He didn't talk about the solid aluminum chloride reacts with water. So what he didn't mention was, what's mark number 2 for? I said, name the type of reaction. That's hydrolysis. For that, he just gave 1 mark for any of the points. So maybe the precipitate thing would also get you mark, but there's only 1 mark for any of these. And the second mark was for the type of reaction, which is hydrolysis. So you got to remember that when you do chlorides with water, NaCl is the only one that NaCl and MgCl2 are the only ones that dissolve in water. NaCl dissolves in water, forms a neutral solution. NgCl2, it mostly dissolves, but there's very, very slight hydrolysis. There would be some reaction with water to form magnesium hydroxide and HCl. So the pH would just be very, very slightly acidic, but very little reaction. It's mostly going to dissolve. AlCl3 strong hydrolysis, the SiCl4 strong hydrolysis. The other ones, they also are going to undergo a very, very strong hydrolysis. So that's this. So try and now complete the papers that I've sent on Google Classroom. Okay? Make sure we'll probably continue with this one in the next class. And the next one was that's mostly organic. We just left one part. So we'll probably continue this
Sir?
in the next class. ठीक है? हाँ जी, हाँ जी.
सर इन क्वेश्चन से ये इनऑर्गेनिक का सेक्शन इसकी काफी ज्यादा वेटेज नहीं है इस पेपर में?
हाँ, इस पेपर में it's there's a lot of inorganic. नहीं, not
सर से
नहीं,
नॉर्मली होगा.
just a second. Not really a lot of inorganic. It's the inorganic. There's only one inorganic question, which is that's a big question. This was about ionization energies. That wasn't inorganic. Okay. The Cl2 was for water purification. This was about Boltzmann distribution energies. So question number 2 was about. So question number 2, how many marks did it have? It's still not ending. And this is probably a most question. So otherwise, question number 2, it's a 23-mark question, but it's got organic. So probably it's I mean, at the end of the day, it's just 12, 13 marks on inorganic. They're out of 60 marks.
ओके सर.
क्योंकि
सर वो आप
हाँ,
सर वो आपके पास जो रिकॉर्डिंग्स है वो आप सेंड कर सकते हैं मंडे और ट्यूसडे की.
बस ठीक है, अभी मैं पहले सॉर्ट आउट करूँ कि मैं सॉर्ट आउट करता हूँ कि मैं इसकी सेटिंग्स वगैरह देखता हूँ. ठीक है, वो मैं देखता हूँ ताकि ऑटोमेटिकली ना वो हो जाए और मैं लगा देता हूँ उसको. ठीक है,
सर
मतलब
शायद वो इस तरह से भी हो सकता है कि वो अपडेट के साथ हुआ हो.
नहीं, वो अपडेट के साथ हुआ है, लेकिन अब वो है कि ऑटो पे सेव नहीं हो रही ना. मैं और मसला ये है कि वो दो इकट्ठे नहीं हो रही. पहले होता था वो एक शुरू होती थी, दूसरी ऑटोमेटिकली उसके पीछे खुद ही हो जाती थी. अब वो मसला बना हुआ है. मैं अभी सेटिंग्स देखता हूँ. ठीक है, चलो ठीक है. ओके एवरीवन, टेक केयर.
ओके सर, अल्लाह हाफिज़.
Okay.